healthy students. Today we are going to study some example networks. Now we have already studied what a computer network is. We have studied the architecture of a computer network. We have seen two reference models, which were the OSI reference model and the TCP IP reference model. Now today we are going to study some example networks. So we will start with the most important example network, that is the internet, and see how this internet evolved over time. But to begin with, we know that a computer network covers different types of networks. When I say different types of networks, that means they may differ in terms of how large or how small they are, right? So how large or how small a computer network is the scale of that particular network. So by large and small, I mean how large a geographical area that network covers or how small a geographical area that network covers. Then the networks may have different goals, like in some cases you may want some reliable connection oriented services, whereas in some cases you may want connection less services with on-time delivery. Different technologies may be used. So we have a variety of computer networks. Now we will see some example networks. To start with, as I said, we will start with the most commonly or the most widely used network, which is the internet. So this is the best known network because from a child to an old age person, every layman knows what an internet is. And since everybody knows what an internet is, so I can say that this is the best known network. What is an internet? Internet is a collection of different networks which are interconnected together. They may be two LANs, they may be two a LAN or WAN. So it is basically a collection of different networks which are interconnected. And such networks are interconnected which use some common protocols. Now, why do I need some common protocols? Because we know that for any two hosts, whether they are on the, if they are on these different networks, and if those hosts want to communicate, it is quite obvious that they need the same protocols for communicating. Because what do the protocols do? Protocols decide the set of rules for communication. So you must have the same set of rules for communication, only then you can communicate. So even if two hosts on different networks want to communicate, those two networks must be using same protocols. So network use certain common protocols and provide common services. Common services include your file transfers, email, video conferencing, voice calling, web searching. So all this includes your common services. So we all know all these things are something that we usually know about internet. Now we will see the evolution of internet. That is how the internet evolved over time and how did we get the internet that we use today. To start with, it all started with the academic and research purpose, right? So it was named ARPANET, which stands for Advanced Research Projects Agency Network. So the first internet was basically your ARPANET, or it was, you can say that it was the starting of an internet. We could not really call it internet, but this is how internet started. So it was the ARPANET, which stands for Advanced Research Projects Agency Network. So ARPA means Advanced Research Projects Agency and NET stands for network. So this ARPANET was basically designed for the academic and research purpose. So academicians or people in the defense who wanted to do some research work used ARPANET. So it was the first wide area packet switched network. It was a wide area network and the technology that it used was packet switching. So it was first such network which used wide area packet switched network. Also, it was the first network to implement the TCP IP protocol suite. The TCP IP protocol suite has various protocols and ARPANET was the first network to implement all those protocols of TCP IP. Now, so the packet switched network and the TCP/IP protocol suite, these were the two important components that became the technical foundation of the internet. So today's internet, the technical foundation of the internet that we have today was laid by these two technologies, these two components rather. The first of all, packet switching was used in the network, and then the TCP/IP protocol suite was used. So these two components became the technical foundation of the internet that we have today, and these two things were first used by ARPANET only, the wide area packet switch network and the TCP/IP protocol suite, the two components which laid the technical foundation of your internet. It was established by the Advanced Research Projects Agency that you call ARPA of the United States Department of Defense. So it was initiated by the Department of Defense that you also call DOD, right? Because it wanted some kind of a network which was less vulnerable to hackers or attackers, because the telephone lines that were previously used were prone to attacks, were quite vulnerable. So it wanted a kind of network which would be more secure. So with this intention, the Department of Defense of the United States established the Advanced Research Projects Agency, ARPA, and this network was then known as the ARPANET. Okay, later on it was used for various research purposes by the academicians also. Now, then with time, the importance of ARPANET diminished as other networks became more dominant in the mid-1980s. Once a network was introduced, later on other networks also started getting introduced. So with those networks, the importance of ARPANET started to diminish. The National Science Foundation Network, which is also known as NSFNET. NSF stands for the National Science Foundation and NET stands for network. So the National Science Foundation Network replaced ARPANET as the backbone of internet. Now till now your ARPANET was considered as the backbone of internet, but later with time, as new networks emerged, one such example network was your NSFNET, which stands for National Science Foundation Network. It replaced ARPANET as the backbone of internet in 1986, and then ARPANET was finally shut down in 1989. Now if I talk of NSFNET or the National Science Foundation Network, it was also a wide area network. Just like the ARPANET, NSFNET was also a wide area network. Again, it was developed by National Science Foundation. So that is why NSFNET, like the ARPANET was developed by the academic and was developed by the Advanced Research Project Agency, the NSFNET was developed by the National Science Foundation, right? So one advantage of NSFNET was that it made high-speed networking available. So with the introduction of NSFNET, we had high-speed networking to national computer centers and interlinked regional networks. So whatever national computer centers were there at that time in the US and the regional networks that were interlinked to the national computer centers, to these the high speed networking was made available with the help of NSFNET. And then it further created a network of networks, many networks interlinked or interconnected with each other, and this is what led to the foundation of today's internet. Now if I talk of the internet usage, two things are very important for internet usage. The first thing is your TCP/IP reference model, and the second thing is your TCP/IP protocol stack, right? The reference model, which consists of the host to network layer, the internet layer, the network layer, and the application layer, and the protocol stack, which consists of various protocols like DNS, FTP, SMTP, that we studied in our previous videos. So these two components, the reference model and the protocol stack, were the glue that held the internet, and in today's date also it is the glue that holds the internet together. So the TCP/IP reference model and most importantly the TCP/IP protocol stack are the two important components that hold the internet of even today's internet together. So a machine can be considered to be on internet if, this is very important, a machine is on internet if it runs the TCP/IP protocol stack. It may use any reference model, but the protocol stack that it must use is the TCP/IP protocol stack. So if a machine that is on internet, so if a machine runs the TCP/IP protocol stack, then it can be considered to be on internet. So every network, or the internet that we call worldwide, uses which protocol stack? The TCP/IP protocol stack. Now, using your using this particular NSFNET, that is the National Science Foundation Network, which uses your TCP/IP reference model and the TCP/IP protocol stack. Any PC, by PC here I mean the personal computers, any PC can call up an internet service provider using a modem. So obviously to use internet you need a device which is built inside the computer, or which is fitted inside the computer. Sometimes the systems come with an inbuilt modem, and in previous days you had the systems wherein you had to fit in a modem separately. So what is modem? Modem is basically a modulator and a demodulator. The name itself comes from the fact that it can modulate and demodulate signals. Hence we call it a modem. So modulating signals, that means these digital signals that the computer produces are converted into analog signals, and then demodulating means the analog signals that the computer has, that the modulator has converted, can be converted back into the digital signals of the computer. So this is the task of the modem, to convert digital signals into analog signals and then to convert the analog signals back into digital signals. The task of converting digital signals to analog signals is known as modulation, and the task of converting the analog signals back into the digital signals is known as demodulation, and hence this device is known as modem. Modulation and demodulation, hence modem. So this is one such device which is very important if you want to use the internet. Then if a PC has a modem, then using a modem, this PC can call up an internet service provider. Now what are internet service providers? Internet service providers are the companies basically which provide you internet. You pay them monthly charges or on whatever basis, and then these companies provide you the internet. So these are your internet service providers. For example, if you have a broadband connection of Airtel, then Airtel would be your internet service provider. If you have a broadband connection of say BSNL or any other company, then that company would be your internet service provider. So in a simple language, any such company which is providing you with internet for the charges that you pay is your internet service provider, right? So using a modem, the PCs can call up an internet service provider, and then in order to access the internet, these internet service providers assign temporary IP addresses, right? The IP addresses are your logical addresses of the system which are assigned to you if you want to use the internet, right? These IP addresses are temporary, that means they can be changed. For example, right now you are using internet, your internet service provider provided with you a particular IP address, right? But if you disconnect from the internet and next time again if you want to connect and call up the internet service provider for the connection, then you will be assigned a different IP address. That is why I say temporary IP address. Of course, since you are using the TCP/IP reference model and the TCP/IP reference protocol stack, so the address here is also known as the IP address. And even if you don't use the TCP/IP reference model, but in any case, all the networks use the TCP/IP protocol stack. So the the address that they are assigned is known as the IP address, which is the internet protocol address, right? So when a PC using a modem calls an internet service provider that I want an internet connection, then the internet service provider assigns a temporary IP address to that particular PC. And then that particular PC can send IP packets to various hosts, either on the same network or on other networks. So packets are also known as your IP packets. So the protocol suite that you use, the protocol stack that you use is the TCP IP protocol stacks, and hence the IP packets or the data messages in a simple language that we call the messages that you send are known as the IP packets to hosts. What are these messages? These are basically the data and information that you transmit sitting at your PC to someone else's PC, either on the same network or on the other network. So this is how it works. Now, up till early 1990s, this NSFNET and the ARPANET, all these were used for academic, government and industrial purposes only. So only academic organizations, like you have www.edu. So any such organization which ends with edu is an educational or academic organization. Or a government organization, like you have www. Like nowadays you are using for the CoWIN app, like you use cov.gov.in. So any such organization that uses gov is a government organization, and any such organization that uses IN, right? So it is an industrial organization usually. So up till early 1990s, this network was used by only academic people, government organizations or academic organizations, government organizations and industrial organizations only, basically for research purpose. So all the researchers, whether they were in the academic field or they were in some government organizations or they were in the industries, they used these networks for research purposes. But then came the World Wide Web, which you call www. So this www is used everywhere, you know, right? Even a layman would tell you what www is. It is the World Wide Web, whether you use www.google.com, www.facebook.com, anything, World Wide Web is there. So this World Wide Web brought non-academic users. Now it's not just the academic users who are using the internet. Every person is playing around with the internet now, be it a 4 years old child or a 75 years old person. So they are not researchers specifically, they are not academicians, or they are not people, government researchers, or they are not industrial researchers. They are just any common people who want to use internet, and they are also using the internet now. So this was made possible with the help of the World Wide Web, which is the www that you call. So basically it made possible for a site to set up a number of pages of information. One single site consists of information of various pages, and then it consisted of your text also, your pictures also, your sounds, your videos, and links to other pages also. So take the simple example of your Facebook page. It has text, yes, you can send messages, you can post using some text, then you can post pictures, then you can have videos in which there are sounds, you can have just audios, of course you can post some videos, then there are links to other pages also. You open the home page and then there are links to so many pages. If you want to see your photos, you click on the hyperlink of photo. A hyperlink, a symbol comes. This is the hyperlink symbol, usually in the form of a hand. So you just click on that link and you are navigated to the other page from the home page itself. Just on the home page, when your home page opens, just click on photos. That is your hyperlink. So the moment you click photo, you are navigated to some other page of photos. So a single page consisted of text, pictures, sounds, videos, links to other pages also. So basically one single site had a number of pages of information. So this was all due to the World Wide Web. All thanks to the World Wide Web that today everyone around is playing with the internet. Of course, it has made things much easier for us than they were earlier. Okay, now when this is such an important thing, I mean, it has made our life so easier, and we are studying specifically this thing, you know, we are studying networking, so it is very important for us to know what is the architecture of this particular internet. So the architecture, if we look at the architecture, it is like this. So you have, of course, to start with, you start with a client who is sitting at his home with a personal computer. So this is basically your personal computer, right? We'll start it if we explain in a simple manner. The best thing that you can think of a client is a person who is sitting at his home with his personal computer or laptop. So we start. So to begin with, the most simple client that we can think of is a user sitting at his home with his personal computer. So it all starts with the client. Then there is a telephone system. The telephone system is then connected to the POP, which is known as the point of presence, and the protocol that is used at the point of presence is known as the post office protocol, right? So the POP basically stands for the post office protocol, which is used at the point of presence. The post office protocol we will study in detail later. Then you have the regional ISP, that is the internet service provider of that particular region. Then this regional ISP is then connected to the backbone of the internet. This backbone is further connected to the NAP, which is known as the network access point, right? Then this network access point is connected to routers, and these routers are then connected to the server farm, right? And these routers are also connected to the corporate LANs. So this is an overview of the internet, wherein it all starts with the personal computer, which is connected to the telephone system. The telephone system is connected to the point of presence. The point of presence is connected to the regional internet service provider, and the regional internet service provider is in turn connected to the internet backbone. The backbone is then connected to the network access point, which is the NAP, and the NAP in turn is connected to the routers, and these routers are then connected to the server farm and the corporate LAN. Now let's look at this in detail. So as I said, we start with a client who's sitting at home and who wants to access the internet. So what our client does, our client calls her internet service provider over a dial-up telephone line. So using a dial-up telephone line, you call your internet service provider, right? Of course, the most important thing that is required to have an internet connection is your modem. So a modem is basically a card which is inserted within the PC. This converts your computer's digital signals to analog signals, also the analog signals back to the digital signals, right? Why do we need a modem to convert the computer's digital signals to analog signals? This is because the analog signals can pass without any hindrance over the telephone system much easily. So it is easier to transmit the analog signals unhindered over the telephone system. That is the reason for converting the computer's digital signals to analog signals using a modem. Now the analog signals which are transferred to the internet service provider's point of presence. What is point of presence? It is an access point from one place to the rest of internet. This is one such place from where you can access the entire internet. So to access the entire internet from one point, would you need the point of presence? So the analog signals which are converted by the modem are transferred to your internet service provider's point of presence, from where you can access the internet. Then these analog signals are removed from the telephone system, right? And from the telephone system, they are injected into your internet service provider's regional network. To travel till the regional network, the telephone system is required, right? But once they enter into the telephone system, they are removed from there, and from there they are injected into the regional network of your internet service provider. So you call the internet service provider using a dial-up connection. Then using a modem, of course, if it is a dial-up connection, so the signals to travel unhindered, they need to be analog signals. So first of all, the modem converts those analog signals into the So first of all, your modem converts the digital signals into analog signals, and then they are passed on to the telephone system. Then they are removed from the telephone system and then injected into the regional network of the ISP or the internet service providers. From here on, the system is fully digital and packet switched. Okay. Once these analog signals are injected into the internet service provider's regional network, that means they are again converted back into the digital signals and from here on they are fully digital and packet switched. So digital signals which are using packet switching technology. So the ISP's regional network has interconnected routers in various cities the ISP serves. Now this one ISP, just for example take your Airtel. If your Airtel is your internet service provider, it is not serving just one city that you know, it is serving various cities. So the regional network of Airtel will have routers interconnected in various cities, so that it is well connected among different cities. So this Airtel will have various routers from one city to another which are interconnected with each other, right? So this is what it says, that the internet service provider's regional network has interconnected routers in various cities that the internet service provider is serving. If a packet is destined for host served directly by the internet service provider, packet is delivered to that host, right? So that means if the internet service provider is serving in one city, say Dehradun, and the same internet service provider is serving in Delhi also, and if the packet is destined for Delhi, for a host which is in Delhi, host means the computer or machine which is in Delhi, so in that case your ISP will directly transfer it to that particular host, because the ISP of Dehradun is also Airtel and the ISP of Delhi is also Airtel. So it wouldn't be a big deal for Airtel to transmit your message from the whole computer in Dehradun to the computer in Delhi, right? So this is what it is. That is, if the packet is destined for host served directly by the internet service provider, packet is delivered to the host, right? Or else, if there is some other service provider, if the packet is destined for a host which is provided internet by some other service provider, the packet is handed over to the internet service provider's backbone operator, right? So if it is destined for a host which is serviced by a different ISP, then in that case it is not directly handed over to the host. In that case the packet is first of all handed over to the backbone operator, and then from there on it is handed over to the host for which it is destined. Now major backbone operators are your telecommunication companies. So major backbone operator companies are your AT&T and the Sprint, right? The full form of AT&T, since I said that if a packet is destined for a host which is serviced by different ISP, then it is handed over to the ISP's backbone operator. So you must know what a backbone operator is. So this is what I'm telling you now, that the major backbone operator companies are your AT&T and Sprint. Now AT&T stands for American Multinational Telecommunication Company, right? American Multinational Telecommunication Company. It was the world's largest telecommunication company and the first one to start with. Then there was Sprint, which is the American Telecommunication Company again, and it was later merged with T-Mobile. Both these backbone operators, or both these companies, they operate large international backbone networks with thousands of routers connected by high bandwidth fiber optics. So basically the backbone networks consist of thousands of routers, and these routers are connected by high bandwidth fiber optics. So fiber optics is a connection oriented transmission lines which consists of fiber optics. So basically all these routers are connected to connection oriented lines which are your fiber optics, obviously, which are high bandwidth. So this is your backbone. Backbone basically consists of all the routers which are connected by high bandwidth fiber optics. And the example backbone operators I've just told you, they are AT&T and Sprint, both being American multinational telecommunication companies. Now, large corporations and hosting services that run server farms. Now, you saw in the architecture that there was a server farm also. If you can see these routers, the backbone, as I said, is connected to the network access point, and the network access point is in turn connected to the routers, and then these routers are connected to the server farm. So what the server farm is? Server farms are basically machines that can serve thousands of web pages per second. When there are, obviously in the internet there are thousands of web pages that are requested every millisecond, right? So when there are thousands of web pages, so to serve those thousands of web pages in a second, you have server farms, and these server farms are the machines that can serve thousands of web pages per second, and they connect directly to the backbone, right? Now, if packet given to the backbone is destined for ISP is served by the backbone, then it is sent to the closest router and handed off there, right? So if a packet that arrives at the backbone, if it is destined for the internet service provider, that which the backbone is serving, right, or which the backbone is providing services to, then in that case it will be sent to the closest router of the backbone. So if this is the backbone and this is the closest router, and if the packet is destined for a different ISP which is served by this backbone only, then it will send directly to its closest router. Else, if it is not destined for an internet service provider which is served by the backbone, in that case all major backbones connect at the network access point. So even if it is not an internet service provider that is served by this backbone, in that case the packet will be sent to the network access point where all the backbones connect. So from this network access point, it will move on to some other backbone for which is serving that particular internet service provider to whose host your packet is meant to go. So basically what is happening, the packet is first going to the regional internet service provider. And then from these regional internet service providers are connected through various routers of different cities where this particular internet services provider is providing you services. Now let us take an example of Airtel or BSNL. Say for example, my packet was sent from a host whose internet service provider was Airtel. Then this internet service provider had a packet, and then this packet was destined for a packet at host which was again served by Airtel. So in that case, the internet service provider directly sent the packet to that host. But if in case this packet was destined for BSNL, in that case the packet first was sent to the backbone, right? Packet was first sent to the backbone. Now if this backbone is serving BSNL, this backbone must be serving various service providers, must be connected to various service providers. So if this backbone is providing services to BSNL, in that case the packet will first of all go to this backbone, and from here it will directly go to the routers and then sent to the destination. But in case this backbone is also not serving this particular BSNL, in that case this backbone will send the packet to, instead of sending it to the nearest router, it will send to the network access point. Now this network access point is the point where all such backbones are connected. Now this is one such backbone, but various such backbones are connected directly to the network access point. And then there will be one such backbone which will be servicing BSNL also. So in that case, the packet will be sent from this backbone to the network access point, and from the network access point to the other backbone which would be servicing BSNL. So this is how it works. So this is what it says here, that if the packet is given to the backbone destined for the ISP which is served by the backbone, then it will send it to the closest router and it will be handed off there. The packet will be handed off there. But if the backbone is not providing services to that particular ISP to which the packet, for whose host the packet was destined, in that case it will be sent to the NAP, because all the major backbones are connected at the NAP, and then from the NAP it would be sent to that particular backbone which is serving the ISP to whose host you want to send the packet, and from there it would be sent to that particular backbone, and from that backbone then it will send it to this nearest router, and the packet would be handed off there. And of course the router will then choose an appropriate line for sending it to the destined host. So NAP is basically you can imagine it as a room full of routers where you have at least one router per backbone. So there are so many backbones which are connected to this NAP. So there is at least one router per backbone. You may have even more than one. So basically, technically, if I talk, it is a point from which an internet service provider drops down its lines and establishes a peering arrangement to provide internet connectivity to customers. From this point, the internet service provider is providing the services to the customers. Now, the local area networks or LANs in a room connect all routers to forward packet from any backbone to any other backbone. So these are various LANs, as you could see that we have various LANs here. So these are the LANs that are connected to backbones through the routers. The LANs first of all connected to all routers, and these routers then forward packet from, because these routers are then further connected to the backbone. The LANs are connected to the routers, so LANs send the packets to the routers, and the routers are connected to the backbone, so the routers then send the packet to the backbones and have then numerous direct connections between their routers, and this technique is known as private peering. That is, this technique wherein the LAN is connected to the router, so the LAN sends the packet to the router, and then these routers are connected to the backbones, so the packets are then transmitted to the backbones, from wherein they are transmitted either to the host or either to the network access point if they are for a different ISP which this backbone is not serving. So in any case, they are handed over either from the router to the backbone and then directly to the host, or from the backbone to the network access point and then to the backbone and then to the backbone which is servicing the internet service provider, to whose host you want to send the packet. So this technique, from the LAN to the router to the backbone, you have a LAN, then connected to the router, then connected to the backbone. This technique of having numerous direct connections between routers is known as private peering. So this is all for today. The example networks that we have seen. We have yet many more example networks to see. This was just part 1 of the series. I hope you understood.